This is the tip of the Beara Peninsula. It's a landscape that's stunningly beautiful, but its geography can make it difficult to survive on. In the middle of the 19th century, the natural resources of this area produced great wealth and employment. Not from the land, not from the sea, but from the copper in those mountains. These hills once echoed with the sound of heavy industry, which changed the community, the landscape itself, and helped with building Ireland.
In this series, our team of experts in architecture, engineering and geography is exploring the most amazing stories of Ireland's building and engineering heritage. And in this episode, we've come to rediscover the copper mines of Beara.
Copper mining has a long history in the area, but the boom came when new technologies, capital and markets brought a whole new industry.
When the Industrial Revolution thundered into remote West Cork, it changed everything. And engineer Tim Joyce is investigating the transformative technology.
Steam-powered machinery dramatically accelerated productivity. There was a huge steam engine here, and this engine house is one of the finest examples left anywhere in the world.
In the foothills of the Caha Mountains, heavy industry had a big impact on the remote fishing village of Alahis. The story of this community is being explored by geographer Mary Green.
It's difficult to imagine now, but the prospect of work brought thousands of miners here from all over Munster. This tiny rural village became the new Wild West mining town and brought stories of success, struggle and strikes.
The geology here is full of telltale signs of a mineral-rich area. These red sandstone mountains were formed 400 million years ago, when the area was covered by red desert sands. Later, after these hardened, the rocks buckled and folded under tectonic pressure. Cracks were filled with mineral-rich fluids, which in turn formed copper-rich quartz veins.
Copper mining has been going on for around 4,500 years in Ireland, and some of the earlier workings are found here on the Beara Peninsula. And those early miners knew exactly where to find the copper deposits.
The Beara coastline is dotted with stunning geological features, but the mark a copper miner needed to look for was green. Malachite is the characteristic green for oxidized copper, and a sure sign that embedded within the quartz deposit is chalcopyrite, the copper-bearing ore. To extract the valuable chalcopyrite, you would have to dig deep into the vein, often going below sea level. I'm heading down to meet mining heritage expert Theo Dalka. He says it's easy to find the copper. I'm just having difficulty finding him.
Hi Theo, I followed your directions, but it took me a while. How are you doing?
Excellent, great to meet you. You really found me here.
I did. It's a fabulous setting.
It's especially on a day like this, it's just stunning.
So Theo, where are we now?
We sit at the foot of a nearly 15 meters high quartz vein. This is actually the place where in 1812 Bearhaven Mines was opened up to reach the copper ore that they were after. I picked up a sample in there for you, and on this side we have it all the white quartz, and here the golden bits.
Oh wow.
This is the chalcopyrite. Some say fool's gold for it, or peacock ore because it has this shiny, lovely glimmer.
It's fabulous.
Within here you have these speckles of green greyish. That would be the malachite, a staining from the copper ore. The rain and the water transports the copper, and then it builds these green layers. And the green was always a sign for a miner.
The green was telling him that this is where you
Absolute.
can find some copper.
Absolute.
Can we have a look inside?
You want to go with me inside?
I would love to have a look.
Jeez, you're brave. Yeah, come on, I'll bring you.
Brilliant, fabulous.
Cutting into the quartz vein to extract the ore was done by hand, using picks, chisels and wedges. They chased the streaks of colour in the rock face and advanced deeper and deeper inside the vein. Wow, this is absolutely incredible. Look at all of this green staining.
It's amazing, yeah.
So it's almost like we're in the heart of this vein and it's just permeated through with this ore.
Absolutely, this is the heart of the vein. And it goes on this side, it goes on that side, and it's deep, maybe another 1,000 meters. We really don't know.
It's absolutely incredible. It really is like an Aladdin's cave in terms of colours.
It is, it really is. It's a playground for geologists.
The quartz deposits, also known as lodes, are hidden underground, but in places are revealed on the surface of this valley. In 1810, when the scale of the copper ore deposit was first reported, the local land agent, John Levalian Puxley, saw an opportunity. The tiny fishing village of Allihies was about to become the centre of a mining boom, and geographer Mary Green is discovering what happened.
The Puxley family were the local gentry who arrived in Ireland during Cromwellian times. The local community were poor, Irish-speaking Roman Catholic subsistent farmers with little, if any, education. But with the arrival of copper mining, everything changed dramatically. Puxley's Bearhaven copper mines attracted hundreds of people from all over Munster. There was work for men, women and children. At its peak, the company had work for 2,000 people, with twice that number living off the proceeds. This town was quite literally built on copper, but there was nowhere to house everyone. Irish families shared accommodation, with instances of dozens of people living in two-room cottages. The pubs were packed and there was a continuous scramble to get work. In 1835, the most valuable import landing into Castletownbere was 15,000 gallons of whisky, and Allihies was awash with cheap labour. But whisky wasn't the only valuable import. I'm chatting with Tygo Sullivan, who runs the local copper mine museum, to get a better picture of what else was arriving in Allihies to change the village.
John Puxley was known as Copper John. He was the dominant character on the Beara Peninsula. He was the land agent. He was all-powerful, but he was also what you might describe nowadays as an entrepreneur. He was a chancer. He took risks. Very early on, John Puxley knew that he had to bring in expertise. He had to bring in people who knew how to mine. And he went to Cornwall, where the Cornish mine captains have been mining copper and tin for many years. These were men who were bred to be mine captains. They were the men that he depended on to make this show work, to make it run as he wanted it to run. And they decided on a Monday morning who was going to work and who was not.
So that would have created divisions on an everyday level?
Yes, there was constant strife, as you might say. There was always a division. And they had their own mine captains' houses. They're still in Allihies. They're still to be seen. They were different to the hovels that the Irish were living in. So there was a big difference. There was a huge difference between the Cornish and the local population.
At the southern tip of the village, the old Methodist church, built for Cornish miners and their families, is still part of the mining story in Allihies. It's now the mining museum and holds a fascinating piece of archive. This is the cost book of John Puxley's mining operation, and it contains an exact record of the profits and expenditures here at the mines. But these accounts contain a lot more than just facts and figures. They provide a window into the cutthroat nature of the mining economy here in Allihies. There was no direct employment here. Miners worked essentially as freelance contractors, paying the mining company a rental for tools, gunpowder and the transport of ore. Even their shovels were weighed for wear and tear. Mine captains auctioned jobs of work, or bargains as they were called. Miners then bid for jobs. There was good money for difficult or dangerous bargains, but less for something easier. The lowest bids always won. Historian Kieran Irene has researched the Irish workforce in the Bearhaven Mining Company.
In the 1850s, there was peak employment in the mines, but the working conditions themselves were very detrimental to the Irish. People were dying. So, for example, there's old miners would refer to timber props and how timber props that were used in mines were actually more valuable to the mine owners than the Irish miners themselves, because the Irish miners were replaceable. And so the Irish had enough, and they decided in 1864 to strike.
So how did the owners respond to this new retaliation from the Irish community?
At the time, there was a decline in the demand for copper, and so the mining owners didn't necessarily need those miners who went out and strike, and so they kept the Cornish employed. And the Irish decided that they would rather seek opportunities abroad than stay with the mines themselves.
What is the legacy of the Irish mining community's experience here, do you think?
Well, I think they came here and they learned a valuable skill set that they could then bring abroad, and also how to retaliate against these unfair working conditions. And we see later on in the 70s, 80s, when they are working in the US and in the mines over there, we see them going out quite frequently on strikes as miners in the US to fight for safe and fair working conditions.
There were 5 mines working in the Allihies area, each with a massive complex of sheds and buildings. This was one of the biggest mining operations ever seen in these islands.
Allihies is full of signs of mining. Within 10 metres of where I'm standing, there are 4 mine shafts, some of which are collapsed. The industrial archaeology is everywhere.
The Bearhaven Mining Company created a landscape of industrial buildings, from stables to dressing floors for rock breaking to forges and kilns for metalwork. Gunpowder was stored in magazines with internal blast walls to prevent catastrophic explosions. Huge reservoirs were constructed high up in the mountains and provided a continuous supply of water for processing the ore and for powering stamps that crushed large rocks. Extracting the ore from the mine shafts was just the start of the process.
Boys were employed in this task of landing the ore, and they tumbled their buckets into wooden carts that ran on tram lines down for sorting.
The rock was brought in wheelbarrows to long, low sheds where women and children sorted it for crushing and washing. I met up with Theodalca again to get an idea of how this back-breaking world of work was changing during the 19th century.
In the early beginnings, the women got the lumps of ore out from the mine, crushing it with her hammer, and the kids, all the kids, were sitting around her, picking up through the rubble, getting out the bits of usable copper. So this gives you an idea of how important child labor was at that time. And we might think it's awful, but they were contributing to the surviving of the family. The whole village would have changed dramatically with the introduction of steam engine and heavy machinery that processed the ore. For most of the families here, it was a disaster because all the women and children, they lost their job. And this thing here, what we found, it just came out of the rubble. This iron kibble was traveling up and down the mine shafts all day long, where it would be filled up with the ore that the miners broke down below with their borers and chisels and hammers. We just found it here, I think, 2 weeks ago. It might be the only one in Ireland.
Piece of history then.
It's a big piece of history. So, Susan, everything was really, really heavy. There was heavy steel, there were heavy machinery, there were heavy carts to tow. It would look like hell. There was fire everywhere, there was smoke everywhere, and you would have noise, unbelievable noises. That was really the sound of the Industrial Revolution.
19th century technological advances revolutionised the mining operations in Allihies. Engineer Tim Joyce is on a mission to discover the transformative power of steam.
The rugged Beara landscape presented a formidable challenge to any industry attempting to exploit a natural resource, especially mining. The Cornish mine captains of 19th century Allihies, like engineers today, didn't get to choose where they went. Sinking a mine shaft this close to the sea with its vast volume of water was a risk. The last thing you want to do is go below sea level. Underground water and its potential for flooding has always been a danger in mining. Thomas Newcomen's early steam engines had become highly advanced by the 1780s, making for a powerful technology. High-pressure steam in a cylinder pushes a piston up, moving a solid iron beam supported on the thick walls of the engine house. This seesaw motion drives a set of suction pumps that reach deep down into the mine. The Newcomen steam engine was at the cutting edge of industrial coal-fired technology when John Puxley made his business plan to advance his mining operations. These machines totally changed the scale of production at Allihies, and more copper meant more wealth. As more mine shafts were sunk and as profits rose, the Bearehaven copper mines were reported in international mining journals. Speculative investors got involved. All year round, barges left West Cork laden with copper ore for the smelters in Swansea. Those barges returned to Ballydonegan Bay, bringing coal to fuel the engine houses. I'm with Brendan Morris, a former mine manager who has a keen interest in mining heritage and the revolutionary impact of steam technology.
During the Industrial Revolution, copper was king, and everybody wanted copper. The UK needed copper, the world needed copper. So steam allowed them to dewater the mines, and that allowed the owners of the mines to extract the ore in an economically viable manner. Because prior to this, some of these mines weren't viable, so they could now mine down at much deeper levels. What that did for them was it gave them access to more working faces. More working faces meant higher productivity. It also allowed them to reduce the costs of shipping by doing some of the crushing underground and some of the crushing on surface to minimise the amount of rock that actually travelled from here to Swansea and optimise what went onto the ships. So the advent of the steam engine allowed them to get production and productivity to a level here where the owners could make serious money.
The biggest, deepest and most productive of all ventures in Allihies was Mountain Mine. It was central to the operations and success of Bearehaven copper mines. Around 1856, this mountain mine reached down 320 metres underground, 1,000 foot. Puxley calculated it took a man 10 seconds to climb down 1 metre by ladder and far longer to come up. As far as he was concerned, this was a huge waste of valuable time. Puxley's solution was a Cornish invention, the Man Engine, which was installed in a purpose-built shaft at the mountain mine in 1862. Hundreds of miners could be transported hundreds of metres. But the real genius of the system was that it could move men up and down at the same time. And yet, each movement was only 12 feet, with miners stepping on and off, as you would with an escalator. This Man Engine house is the finest surviving example in the world.
There's only one way to really understand what this deep vein mining was like in the middle of the 19th century. I've been given special permission to go underground, and University College Cork geologist Betty Higgs is coming with me.
And this was the original, one of the original adits.
Adits, or horizontal passages, burrow in towards the vertical shafts, allowing access for men, machinery and animals.
Oh, wow. But when you shine the light down, you can see how deep these shafts go. And the ladder there is looking very ghostly, but that's how the miners went down to other adits, following the seam around. They had to think in 3 dimensions.
The workings of Mountain Mine are a vast subterranean network of adits, shafts, caverns and chambers that plunged 280 metres below sea level at its deepest point. Vast quantities of rock were blasted and removed from inside this mountain by hundreds of miners. The majority of the mine is now flooded, but I'm hoping to see what they were after and what they've left behind.
It's a particularly nice piece here as we walk past. Look at the amazing colours of the copper ore here. Yeah. This was one of the original 19th century adits. So you can imagine the miners crouching down. So it was claustrophobic, it was dark, but these adits helped the miners to get along to the main quartz seam.
Well, Betty, what was this space?
Well, this is a large cavern. A horse would have been walking around here, driving a windlass, which was winching material from lower levels up to the surface, so the ore could be brought up. It was the beginning of mechanization.
These horses needed looking after, though.
These horses needed looking after, so there would be blacksmiths, there would be tools needing sharpening. It was essentially a whole subterranean world here, practically 24 hours a day.
It's amazing. It's absolutely amazing. Betty, what are we looking at this point?
The importance of this part of the mine can't be overestimated. The fact that these levels and ladders are still in place, we can see how the miners had to climb up, go across the platforms, blasting above their heads, climb up other ladders, and with men standing below you, and you're trying to blast roof material out. What we call stoping, taking away more of the roof, working up the ladder, bringing the material down to this rock level, carting it away, and then going back up. Again, gunpowder, blasting, extremely dangerous work. And this stope is almost unique in the way it's preserved and heading up almost to the surface of the mountain mine.
It's amazing.
The average life expectancy of a miner in Allihies was 32 years.
Here we are on the rock pillars.
It's amazing. Oh, wow.
Wow, yes, yeah.
Absolutely amazing.
So here we are, Susan. We've come to the largest cavern in the mountain mine. We're 50 metres below the surface. So mountain mine was the most productive of all the mines around here. And the intersection of the faults and fractures caused perhaps more mineralisation here than it did in some of the other mines. But you can imagine just working away in the darkness, and at its peak, there would have been 1,500 or more miners in teams bringing the ore in and out. It's wonderful for geologists to come in and learn more about what happened in the last century, but it's a fantastic resource for future geologists, engineers, social scientists to be able to come in here and learn and understand how the miners went about this.
When the copper mines started to close in the 1870s, the majority of the population in Allihies emigrated. During the 70 years they operated in the 19th century, the Bearhaven copper mines were the biggest mining operation in Ireland. Small-scale farmers and agricultural labourers became industrial workers in the harshest of conditions.
Geological good fortune is key to the story of mining in Allihies. New ideas and new machines developed in the pursuit of profit brought the Industrial Revolution to this remote part of West Cork. And the industrial legacy ingrained in its community is now being explored by new waves of visitors.
Lake Mahanigan, way up in the Wicklow Mountains. That's Gaelic for Lake of the River Monster. And today, it does hold immense power. 600 metres deep inside this granite mountain is a hydroelectric generating station fueled by the power of Wicklow waters. It is one of the most magnificent feats of Irish engineering. Built in the 1960s, this entirely man-made complex can unleash over 290 million watts of power into the national grid in seconds. It's a crucial piece of national infrastructure and vital to the story of building Ireland. In this series, our team of experts in architecture, engineering and geography is exploring the most amazing stories of Ireland's building and engineering heritage. And this time, we've come to discover the power of Turlock Hill. Hidden away inside this mountain at the end of a half-kilometre-long tunnel is Ireland's only pumped hydro station. 4 massive turbines sit in a huge chamber carved out of Wicklow rock. They're driven by the force of millions of tons of water that surge down from a colossal man-made reservoir. And because of brilliant Irish engineering, with one gear shift, these turbines go into reverse and pump water from Loch Nahannigan back up the mountain to generate electricity again. Geographer Susan Hegarty is going to explore what's special about this area and why the landscape has the perfect features needed for the power station project.
Mountain waters have sustained human activity in harsh and rugged terrain for thousands of years. But I want to explore how granite and glaciation are key to understanding the power and beauty of this landscape.
Engineer Brian McManus is going to discover more about the technology and engineering that make this scheme possible.
I want to explore the electromechanical systems in this subterranean cavern and understand how this complex plays a vital role in meeting and managing the country's electricity demands.
Building the Turlock Hill Power Station was the biggest Irish civil engineering project of the time. It was the 1960s, and ESB engineers had to come up with a plan to meet Ireland's growing industrial and consumer demands for electricity. The idea to harness the power of a natural resource wasn't new, but what they proposed was visionary. By reusing the raw energy of millions of tons of water, they could deliver hundreds of megawatts of electrical power to hundreds of thousands of homes, just in time for peak demand at tea time, and then put the water back at low demand times. An economic bargain. This tunnel was the first thing constructed, and they had to bore into the hard granite rock to get inside the mountain. Wicklow granite is particularly hard. Cutting a tunnel into the heart of this mountain was a painstaking process of drilling bores, packing in explosives and blasting the rock. The access tunnel needed to be big enough to deliver the heavy equipment that would be buried inside this mountain. With the tunnel complete, hundreds of thousands of tons of granite were excavated to create the cavern chamber. After 40 years in engineering, it's a great privilege for me to finally get to step inside. This cathedral-sized space lies at the heart of the complex and descends through 3 main operational levels below this turbine hall floor. The cavern would have to hold 4 turbines, their generators, transformers and switchgear and cranes, all on different levels. It's 10 stories tall. That's a stack of 7 double-decker buses. This was a complex project that required the skills of civil, mechanical and electrical engineers. different teams of engineers coordinated work on 10 separate aspects of the project, all working to a central design. They had to be precise, accurate and synchronised for the plan to work. 350 workers lived on site in temporary accommodation, working above and below ground. In all, 500 workers were involved during the 6 years of construction until it went into operation in 1974. Water holds the key to this site, and geographer Susan Hegarty is uncovering the geological story of this landscape and how human activity has harnessed the power of a glaciated valley.
420 million years ago, colliding continental plates and cooling magma formed the granite rock of the Wicklow Mountains, part of the largest mass of granite in northwestern Europe. Much later, the Glendassan Valley was carved out through the slow but powerful force of a massive glacier. The sheltered and fertile landscape it left behind attracted the early settlers, including St. Kevin, who founded the world-famous Glendalough Monastery. In geological terms, this landscape was also mineral-rich, so the remote location of the valley didn't deter industrial-scale mining. Copper, silver, lead and zinc were mined across Wicklow over hundreds of years, right into the middle of the 20th century.
This site is known as the Miners' Village, and it's just one of the many lead and silver ore processing sites that dot these mountains. This is part of the Glendalough mines, and here on this dressing floor, rock was crushed and transported down the valley, a process all powered by water.
Stamping mills and crushing rollers were all powered by Wicklow waters flowing down the valley, through the narrow gorges of the upper range. Gravel deposits appear as natural features, but are actually mine tailings and waste materials from old mine works. When searching out and surveying the landscape, ESB engineers were looking for a site with the right features for a modern pumped hydro power station. And where they were going to bury it was critical.
The most common type of bedrock in Ireland is limestone, which is soft and easy to cut and shape. Granite, on the other hand, like most igneous rocks, is hard, and crucially, it's relatively impermeable. Robbie, how are you going?
Susan, how are you?
I'm meeting geologist Robbie Meehan, who knows how Ireland's last ice age helped determine the location of the Turlock Hill project.
What we have this deep armchair-shaped depression, and that's a result of the ice gouging out the bowl that the lower lake sits in, and it gave a natural landscape within which you could actually construct a pumped hydro scheme. That back wall of the cliff there is a couple of 100 metres high. So you're looking at something that looks like it's man-made, but it's natural. This huge big corrie that the lake sits in was the birthplace of the glacial system. It is the area within which the ice starts to flow out over the landscape, and it would have covered everything. So the tops of the mountains were planed, they were ground down, they've been almost bulldozed by the ice. So the power of that ice is quite incredible. And what's unique about Loch na Hannigan is that during the construction of the pumped hydro scheme, the lower lake was drained. And there were sediments there, layers there, that had organic remains in them that could be dated by scientists to 11,500 years ago. And that was the first time that we had a dated layer in the Irish landscape to that time.
And that was the last time ice was ever on this island?
That was. The ice died off at that time, and the climate warmed, and the climate started to get quite wet.
So what we've got here then is this bog forming.
It's called blanket bog. It envelops and covers completely all of the terrain underneath it. And as the vegetative remains don't fully decompose, they become compressed. What that means is that over time, peat can form. The peat grows at a rate of, on average, about 1 millimetre a year. So if we go back down here to the base of the peat sequence, about 1 metre down, we're probably going back about 1,000 years. And Ireland's kind of unique. Over 10% of the country is blanket peat. And Ireland as well has about 8% of the blanket peat resource of the entire world. And because the peat itself is a record of past environments, it's a really important resource.
To get water from the reservoir on top of the mountain to the chamber 300 metres below, the tunnellers faced into the hard Wicklow mountain once again. This time, a pressure shaft was cut. I've been given access into the very first test tunnels sunk into Turlock Hill, so I can get an idea of how the ESB engineers tackled this job from both ends. They bored 50 metres straight down from the upper reservoir, and from below they drilled and blasted over half a kilometre at an angle of 28 degrees to form a shaft for the water. Excavating the raw rock, the drilling teams drove towards each other to cut a vital artery into the centre of the mountain. Once the teams broke through and connected, they set about lining the entire bore with steel. The steel tube sections were assembled on site and carefully lowered into the shaft. They used a really clever rail system to angle them into position, section upon section. The rails carried the weight of each 10-metre long section and allowed for slow and careful positioning with millimetre accuracy. 60 steel tubes were positioned in this way. Welding and painting had to be completed with great care. The tube would have to be ready for the enormous force of the waters cascading through it, so X-ray scans were used to check the seals. The space around the pipe was then encased in concrete. The pressure shaft narrows from a diameter of 5 metres, like this test tunnel, to 3.4 metres as it nears the turbines. This ramps up the power of the flow to drive the 4 turbines embedded at the bottom of the cavern. The entire cavern is below the water level of the Loch Lehanagan. It's a vitally important design feature. It means that the turbines in the cavern are always primed. Water pressure is constantly bearing down on the system, so it's never empty. The turbines can be put into reverse in a matter of seconds and start pumping water back up the mountain, ready to start the cycle all over again. Curiously, before the power station was built, the mountain didn't have a name on the Ordnance Survey map. The engineer who recommended the site, John O'Riordan, decided to name the hill after his son, Turlock. It was a good choice. A turlock is a lake that loses its water through a swallow hole, just like this lake. But everything here is man-made. Engineer Brian McManus is investigating how the water pressure is harnessed with mechanical and electrical engineering.
These valves are designed to intercept in full flow the torrent of water surging through the system. Robust engineering and clever design underpin every moving part in this complex. Deep inside Turlock Hill are the electromechanical systems at the heart of this pumped storage generating station. It's all located in a multi-storey complex in the underground cavern. I'm right down at the bottom of the chamber. This is where the water surges down from the upper reservoir and into the inlet pipes that drive the 4 giant turbines. Each turbine has its own spherical valve, 1.7 metres in diameter, which has to absorb the 500 tons of water bearing down on it every minute. There is no margin for error in the engineering required to control this flow. The high-pressure flow of water provides the energy that then gets converted into electrical power. And this is where the big engineering kicks in. The moving water pushes a turbine that spins a shaft that turns the electrical generator. And the entire system can also be put into reverse to pump water back up the mountain. Above the turbines are the shafts that connect to the electrical generators on the level above. This shaft is now helping to pump water uphill. You can really feel the power. The ground is literally shaking. Whether it's helping to pump water uphill or generating electricity, it always rotates at 500 RPM. With underground space at a premium, mounting everything vertically makes for a very compact design. The size of the cavern was determined solely by the space needed for these mighty machines. Here, on the top floor of the generating hall, we can see the apex of the reverse pump turbine, which is assembled vertically below. Each one consists of a turbine connected to this generator by a shaft with what's called a pony motor on top. At the heart of each one is a stator, a static part, and a rotor, a spinning part. When the system here was being assembled, you could see the essential elements of electricity generation. The stator is made up of a ring of wire coils. Into that is lowered a spinning part, the rotor, which is made up of a ring of magnets. The interaction of the wire coils in a magnetic field produces a flow of electricity. Turlock Hill Power Station can only stay operating for 4.5 hours. The flow of water powering the generators stops when the upper reservoir has been emptied. For every 3 units of electricity generated on the way down, Turlock Hill uses 4 units to pump water back up. To understand how this can still be an efficient use of electricity, I'm meeting Martin Strong, Hydro Stations Manager for ESB. So Martin, we're in the control room here of Turlock Hill. Can you tell me a bit about what these screens mean and what this room actually does?
Okay, Brian, this is not just the control room for Turlock Hill, it's the control room for all the ESB hydro stations. And you can see on this screen the breakdown of the different types of generation that are available on the system. You can see in the green, 41% of the system at the moment is made up of renewables, which is wind and ESB's hydro stations. Turlock Hill is a really, really unique facility. When there is a surplus of generation on the system, a lot of wind blowing across the island, it takes all of that wind generation, it pumps the water up the hill into the upper reservoir, and then later on, when the wind has fallen away, it can then use all of that water to generate again. So the red line on the top here is the demand, and the blue line is wind generation. And what you can actually see is that as the demand was rising, the wind generation was falling away. And Turlock Hill will have been called on then to meet some of the gap there. And the speed allows it to deliver 292 megawatts, which is enough power for 300,000 homes. It can deliver that in 70 seconds. It's much faster than thermal generation, which is by and large what you have elsewhere in the country.
So can you tell me what the role of Turlock Hill will look like in the future?
As we move into more and more renewables on the system, there will be more and more intermittency, where generation is going up and down as the wind changes across the day. And Turlock Hill's speed allows us to get the most out of the renewable generation that's available to us.
When searching for a site for a pumped storage power station, the ESB engineers knew exactly what was needed. A mountain with a deep natural Corrie Lake at its base, close to Ireland's biggest city. For this mountain site to work as a pumped hydro scheme, its natural features would require structures of such scale that the project team would have to engineer the landscape itself. The first challenge was to construct one of the highest roads in Ireland. It would have to snake up 3 kilometres through the blanket bog. To ensure pristine views of the surrounding landscape, the initial stretch of high-voltage transmission cable was buried underground. Heather was carefully extracted and stored, and 1 million tonnes of peat removed to expose the mountain's granite peak. Making the upper reservoir was a monumental task. The granite peak was blasted flat, and the rock was used to build up the bowl-shaped reservoir's edge. An asphalt factory was also built on site to produce a waterproof membrane for the inner lining of the reservoir, the first time the technique was used in Ireland. It took 2 million tonnes of quarried granite to make this rock-filled embankment. It is 1.5 kilometres long and 34 metres high. It was designed and engineered for one purpose: to hold 2.3 million tonnes of water. That's an immense weight, with immense power. The reservoir simply stores potential energy. It's ready to be released when the engineers below decide to fire up the generators. Holding up water like this is still the best way we know to store power. I'm heading for an artificial island in an artificial lake to see how that energy is released. This is the central control tower. It has one of the most important functions, directing the flow of this vast body of water. It's effectively a giant tap. The control tower sits above a plug hole at the bottom of the reservoir. This is where a stopper opens and closes to control the flow of water into the pressure shaft. Storing and releasing such vast volumes of water would put pressure on any system. Micheál Bruin is a fellow engineering hydrologist, and we met up to discuss the forces at work when you've got 2.3 million cubic metres of water sitting on top of a mountain. So 300 metres up, down there, what kind of pressure would it give you?
Well, every 10 metres of water is equivalent to the pressure of 1 atmosphere. So this is about 300 metres above. That means that you have the pressure of 30 atmospheres.
Plus this atmosphere here.
Plus the one
so we have
that's
31.
above us, so 31.
Yeah.
And one way to visualise it, everybody has seen films about submarines, particularly some of the war films. Well, the First World War submarines would have been crushed by the pressure at the bottom of this pipeline. They could go as deep as 100 metres. Even with all the improvements between the wars, most of the Second World War submarines could go to 200 metres. They would be crushed at the bottom of this pipeline at the turbine. So the pressure is immense. And part of the genius of this design, by building it inside a mountain, is that the granite of the mountain is helping the pipeline contain the pressure, because this water is trying to escape.
Any leakage here could be disastrous, but this reservoir has a special inbuilt drainage gallery or tunnel for regular inspections. This underground drainage gallery circles the entire reservoir along the inner slope of the embankment. It collects seepage from the concrete asphalt lining. Anyone who works with water knows there's no such thing as 100% waterproof. Under the immense water pressure bearing down on the embankment, seepage is constantly monitored. Incredibly, almost 50 years since its construction, seepage is only a quarter litre per second, testament to the design, civil works and labour that constructed this reservoir. This project is one of the great feats of Irish engineering, but it is effectively hidden away, buried deep within this Wicklow mountain, unseen and unheard. This power station is an integral part of Ireland's modern sustainable transmission system. You might think this is the future of electricity generation, but Turlough Hill has been up and at it since 1974. In the middle of the 19th century, it took 2 weeks for news and information to cross the wild Atlantic. However, on land, the era of instant communication had arrived with the electric telegraph and the rat-a-tat of Morse code. but you'd have to cross the oceans to wire up the world. Everyone knew that connecting Europe to North America with the telegraph line would transform both continents. This island, Valentia, just off the coast of Kerry, was a hub in the extraordinary scientific and engineering effort to lay the world's longest telegraph cable, vital in creating a global economy and in the story of building Ireland. In this series, our team of experts in architecture, engineering and geography is exploring the most amazing stories of Ireland's building and engineering heritage. And this time, we've come to discover how the first transatlantic telegraph cable got connected to Valentia. The electric telegraph was the first commercial application of electricity. The speed and convenience of messaging changed everything, and a telecommunications industry was born. The wires of the electric telegraph spread like ivy across the continents. The Victorians used terms like creating a network and a web of communications, inventing the language of electronic communications we use today. Cities and countries had telegraphic links, but linking continents was the ultimate goal. Engineer Brian McManus is investigating how they got messages across the oceans.
Sending an electric current underwater is a difficult engineering challenge, but you can do it if you use the right type of cable. Using the wrong one only leads to failure, and disaster is a big part of this story.
With the technology up and running, a cable station complex had to be built on Valentia. Architect Orla Murphy is discovering more about the buildings and community that kept the telegraph humming.
I'm here to explore how architecture met the brief to accommodate high-tech workers in one of the most remote parts of Ireland.
Before the arrival of the telegraph, electricity was just a novelty party trick. But scientists were intrigued by the potential of this exciting form of energy. When scientists and engineers began experimenting with electricity at the beginning of the 19th century, they had loads of ideas that opened up new technologies. Electricity was going to change everything and was going to change communications in the most profound way. Samuel Morse and his practical coding system helped drive the expansion of the telegraph to thousands of cities. With undersea cables, Valentia would become a globally significant hub. Derek Cassidy is a marine telecoms engineer and telecoms heritage enthusiast. He's keen to show me his latest find as he goes to secure a late Victorian undersea cable.
But it's actually, here it is here. I found it the other night. It's a nice one. Let's go down and have a look. See what we see. The cable development comes from 1845 when Henry Bewley, an actual Dublin chemist, came up with the idea of extruding gutta percha, a type of natural rubber, insulation over copper. Gutta percha insulates copper from water. It's brilliant for sub-cables, because before that they had no real way of making long lengths of copper wire covered with a gutta percha. That feat in alone opened up the world to sub-cables. So the best thing for me to do is to get a piece here and I'll begin to cut.
Getting the right blend of rubber like gutta percha as insulation and the right protective covering was no simple task. If the cable was too heavy, it would break. If it was too light, it would float.
Okay. Right, there you go. True. You ready?
Yeah.
Right, there you go. There's the cable.
Okay. Why is it twisted?
It's twisted in such a way that if it gets any damage, it'll actually tighten. If it's turned, it'll tighten.
Okay.
And basically, you're allowed to actually bend the cable.
And if it tightens, it gets stronger?
It does, yes. And the basic concept of submarine cables hasn't changed.
Yeah.
They have the armouring, the insulation, and the core.
Very good. Plans for a transatlantic cable were first hatched in 1854 when an American entrepreneur, Cyrus Field, believed that the technology was ready. A recent survey of the Atlantic Ocean seabed gave him additional confidence. The discovery of a natural plateau or shelf on which a prospective cable could be laid meant that the most eastern part of Newfoundland could link with the extreme southwest of Ireland. In July 1857, a cable-laying expedition of ships assembled in Valentia Bay and took delivery of the 2,000 nautical miles of cable needed for the Transatlantic project. No ship could carry such a weighty cable, so half of it went on the USS Niagara and the rest on HMS Agamemnon. The Niagara set sail, spooling out its half of the cable. And then in mid-Atlantic, the Agamemnon's cable would be spliced on and it would complete the journey. After just a few days, the cable snapped and disappeared into the deep. A second expedition began in June 1858. This time, to speed things up, the two ships began laying the cable from the mid-Atlantic and headed off in opposite directions. Twice the cable broke, and twice they sailed back to pick it up and start again. But when the cable broke the third time, they had to head back to Ireland for provisions. On the fourth attempt, the cable was finally laid on the 5th of August, 1858. American President James Buchanan and Queen Victoria exchanged telegraph messages and sparked talk of a new era of world peace. But then, 27 days later, the transatlantic chatter fell completely silent. Engineer Brian McManus is going to investigate what went wrong.
Getting the telegraph working underwater posed a particular set of problems because fundamentally, electricity and water are a bad combination. Those first transatlantic signals were weak and worsening by the day. In an attempt to jolt the line into operation, the voltage was pushed up from 600 volts to 2,000 volts, but the small copper wire core couldn't cope. Increasing the voltage simply burnt out the 1858 cable, but worse still, it showed that they had an inadequate understanding of the science of electricity in seawater. Electrical current weakens over the length of a wire because of resistance, and a cable stretching 3,500 kilometers across the Atlantic had never been attempted before. Another issue was that salty seawater got through the insulating layer and weakened the current, and they couldn't understand why the flow of electricity seemed to slow down. So, sending a message through a cable under the Atlantic was hugely problematic. The failure of the 1858 cable was considered a huge scandal, and a scientific commission of public inquiry was assembled with some of the finest minds of the era. One of them, Belfast man William Thomson, who would later go on to become the pioneering scientist, Lord Kelvin, questioned whether the cable needed such a significant electrical current for messages to be accurately read. Thomson confounded everyone by saying that a big voltage wasn't needed to send a signal across the Atlantic. Yes, he knew that the current would diminish over the distance, but he found a genius way of detecting really small signals. Thomson's radical solution was based on adapting the prevailing method of detecting electrical current at the time, the galvanometer. I'm meeting retired marine communications engineer Brian O'Daly, who can show me exactly how it worked.
If we agitate a galvanometer with a power source, we can see the needle deflects to one side, but when the current amplification was very, very small, you couldn't know whether there was current flowing or not. So Thomson came up with the idea that he would make not a galvanometer, but a mirror galvanometer, is that he'd put a mirror into an instrument like this instead of a needle. And it turns very, very slightly when it's agitated by current. Thomson's idea was he was fiddling with his monocle, and he saw that there was a reflection on the walls due to it catching sunlight, as I would do so with the face of my watch. And when I shine the light in, we can see that it's reflected out and it can be read on an external surface, and that would prove that there's current flowing.
It's a very simple solution, really. It's just like the mirror, a small deflection in the mirror from the current causes a large deflection over here.
That's right, yes. They needed something that would amplify the signals, and this was the beginning of something very, very new.
The mirror galvanometer was proven to detect signals over 1,000 times fainter than previously possible. Its success allowed Cyrus Field to raise money for a new transatlantic cable venture.
William Thomson also recommended that the copper core was tripled in size, with insulation 100 times more effective. But it made the giant cable twice as heavy. There was only one ship afloat that could carry such a massive cargo. The world's biggest ship, the Great Eastern, was chartered for the challenge. In July 1865, thousands gathered at Foilhammerum Bay in Valentia Island for the big send-off. There was a party atmosphere with singing and dancing, and a large gathering of the great and the good, the local wealthy, and probably a lot of the local poor. Of course, the cable was the star of the event. From the great ship, it was hauled by 100 local men across a pontoon bridge of 22 local boats. With the Irish end secured, and with speeches and prayers for a successful voyage, the Great Eastern headed west into the Atlantic with his flotilla of support ships. The cable was paid out carefully and tested regularly. Any faults were repaired on the spot. William Thomson was on board, and he refined the paying out mechanism to prevent the cable snapping. Then, 2/3 of the way across, the cable broke during a splicing operation and disappeared into the water 2 miles deep. The Great Eastern was forced to return to Ireland. It was yet another failure for the transatlantic project, but despite the disappointment, Cyrus Field raised money for a third attempt. The potential profits for cable companies was so great that they were lining up to get involved. It would take a year to manufacture the new cable. And again, the Great Eastern was made ready. In July 1866, once more, the Great Eastern departed Valentia and steamed out into the Atlantic with the giant cable filling its hull. After 2 uneventful weeks, it approached Newfoundland and 50 men dragged the cable ashore, including Cyrus Field himself. A signal was sent and detected by Thomson's mirror galvanometer. On its first day of operations, the transatlantic cable earned a staggering £1,000. The business boomed, and a transcontinental web of communications was created, an internet for the Victorian age. Valentia was one of those places that really felt the impact. Architect Orla Murphy is discovering how the 19th century tech boom changed the island.
By the 1870s, these once empty fields were transformed into a telecommunications hub and a community.
Once the Transatlantic Telegraph Cable was operational, it was clear that a new permanent station would be needed on Valentia. In fact, a whole campus would have to be built for a new community of up to 200 telegraph operators and their families.
Despite the remoteness of the island, the cable station design wasn't just simply functional and utilitarian. Instead, this new community was to be accommodated in comfort, elegance and beauty around the shared public space of the gardens and tennis courts.
3 separate blocks of workspace and accommodation were built. In the northern block resided the managerial staff. These were homes with running water, electricity, and rooms for domestic servants.
These houses, while quite metropolitan in character, also cater for the weather, with these large glazed entrance porches where you can take off your boots and shelter against the wind. They're sturdy, they're well built, they're robust.
and they've stood the test of time to be adaptable and are still very much loved on the island. I'm meeting one of the residents, Gordon Graves, who can boast a particular connection to the first days of the cable station and to the early cable laying attempts.
Well, my connection is through 3 generations to my great-great-grandfather, who came here in 1865 to supervise the sending of messages as the cable was being paid out by the Great Eastern. So he was operating from a little wooden hut on the top of the cliffs at Foilhammer, in the middle of nowhere.
And did your great-great-grandfather then stay on when the permanent station was set up and the cable was up and running?
Yes, he stayed on and he was appointed superintendent. It was his first of his 44 years here. He always signed himself off as owned-enquiries. That was his nom de plume. So then he persuaded his bosses that they should build a proper cable station nearer to more social activities, i.e. back at Knightstown, instead of right out on the cliffs. Because all the operators had to move backwards and forwards all the time to Foilhammer by horse and cart.
So they knew it would be a much better permanent situation to be located close to Knightstown.
Yes, all the facilities were there, churches and schools and everything for the families, so it was much more compatible family-wise.
The urban, cosmopolitan architecture may seem incongruous for rural County Kerry, yet it is totally in keeping with the high-tech work and educated workforce. Located at the centre of the complex is the cable station itself. Eventually, technological advancements would leave the building behind, and it was put to other uses in the 1960s. Michael Lyne worked here for over 40 years and is showing me where the graphers lived in the old days.
There was no electricity up here since the cable station closed down.
Oh, OK, so this has been empty since then?
It has been empty since then, yeah.
What was the average day of a grapher like?
Well, there were 3 shifts here, from 6 to 2 in the morning, from 2 to 10, and then you had the night shift start at 10 o'clock until 6 o'clock in the morning again.
So it would have been a hive of activity kind of all the way through the day?
It would indeed, yeah. I mean, if you were on the early morning shift, you were off at 2 o'clock, and then you had the evening to yourself. There was plenty of activity. There were 2 9-hole golf courses. There was 3 tennis courts out the front. They had cricket in the sports field next door. Everybody had a sailing boat and lots of regattas every week.
How do you think the station affected the island?
I suppose it had a big influence on the island, and economically as well as everything else. Their wages were supposed to be equivalent to that of a bank manager. So you can imagine 200 bank managers in Valentia.
Wow.
If you were walking down the village and you met a local and a grapher, you would have no problem identifying which was the grapher. He would be dressed in a suit with a top hat and a waistcoat with a gold watch and chain. The local, and then he'd be the guy without the shoes, or if he was lucky, a pair of hobnail boots maybe.
The background chorus of Morse code is long gone, and the houses now are in private ownership. But there are ambitious plans afoot to convert the cable station into a UNESCO World Heritage Site. These buildings, in their function, in their role, in their layout, in their detailed design, have not just left a mark on the island, they've played a key role in what Valentia is today.
Across the Atlantic in Newfoundland, the partner cable station for Valentia is in a little coastal town called Heart's Content. It too closed in 1965 and is now a museum. The Canadian and Irish governments are working together to secure UNESCO status as a transboundary World Heritage Site to celebrate the vital role of both Heart's Content and Valentia in the evolution of global communications. On this day, the 27th of July, over 150 years ago, a message from Newfoundland made telecommunication history.
153 years ago, the very first telegraph message was sent on the very first commercial transatlantic telegraph cable, which effectively opened up communications across the world. And today, along with Sean, we're going to be talking to Heart's Content over Morse code.
Welcome, Ireland!
Sean's Morse message is being carried via an electrical pulse down a dedicated line on a subsea cable, exactly the same as the message exchanged with Heart's Content in 1866.
Okay, so what they said was, our shore end has just been laid and a most perfect cable under God's blessing has completed telegraphic communication between Heart's Content and Valentia.
This one simple message on a proven and reliable submarine cable ushered in a new age. Within 15 years, there were 100,000 miles of undersea telegraph wires and countless telegraph stations relaying messages, now called cables. The benefits to business and communication were obvious, but increased international cooperation had unforeseen benefits. Units of electricity had to be agreed upon, like the watt, volt, ohm, and ampere. Telegraph technology continued to develop and advance, from manual Morse code messaging to ticker tape to automated readers to telephone and eventually radio communications. Societies and economies were affected at a most fundamental level. This telegraph cable was a tiger let loose in the business jungle. Companies had to run with it or die. The resulting stampede of transatlantic messaging has driven technological advances to this day. I'm on my way to meet someone who believes our communications history and industry owes a debt of gratitude to Valentia. Leonard Hobbs is Trinity College Director of Research and Innovation.
When we look at what it was, a telegraphic system, how has that helped bring us to where we are now?
What we now live with today is instant communication. There's 188 million emails sent in a minute, compared to when this cable started in Valentia in 1866, there was maybe 4 words could be sent in a minute. So it's made the world a smaller place. What also began here was engineering, electrical engineering in particular. So the world's been transformed by communication, by this kind of internet connectivity technology, and it all began in Valentia.
What are the impacts to Ireland from the developments that were made here in Valentia?
It was the start of Ireland's technical journey, really, that today, has led us to the point where we've got every multinational in the US now has a place in Ireland. And it all began again with, I think, here, when established a kind of a confidence and a competence in this new thing called engineering and technology.
Today, 99% of the world's international data traffic is carried not on satellites, but on 400 subsea cables that span the world's great oceans. The telegraph made the world both faster and smaller, and launched us on the trajectory of the modern age of digital communication. The Transatlantic Telegraph Cable was the wire that changed the world.
In the bleak 1950s, amid economic stagnation and emigration, they started building factories and a brand new town on the northern marshy bank of the Shannon estuary. It seemed like a crazy scheme. Project X, an urban development in rural County Clare, and the world's first air-age industrial estate. And it was an idea that didn't stop there.
International industries arrived and created work. This led to an economic development model that helped change the global economy.
Constructing a new town at Shannon to service global industry was a turning point in rural development and in building Ireland.
In this series, our team of experts in architecture, engineering and geography examines some of the amazing stories of Ireland's building and engineering heritage. And this time, we've come to discover the origins of Shannon Newtown.
In a little under 10 years, this landscape was totally transformed, and that's really interesting for me as a geographer. Shannon Newtown was built on a radical vision for economic development using the latest ideas in town planning.
This was a project full of ambition. Factories, offices, shops, homes and schools were built on a greenfield site. There were even plans for futuristic office blocks. Shannon was a model for rapid development, and the idea would reverberate all around the world. And it transformed the lives of millions, especially in China. Shannon was Ireland's first new town in 300 years, and architect Orla Murphy is investigating what exactly was built.
The very first housing development here didn't just have to build homes for Shannon's new workers, it had to lure them here. Drumgeely Hill was a bold statement of intent that this town was going to be different and fundamentally modern for 1960s rural Ireland.
How a community of pioneering settlers took root here is being explored by geographer Mary Green.
Flash economics and fancy new flats are all very well, but how do you build community in a town where everybody is from somewhere else?
Shannon Airport was a beacon of modernity in a depressed west of Ireland. With the arrival of the jet engine in the 1950s, the activity and jobs here were suddenly under threat. If planes didn't have to stop off to refuel, maybe the jetliners could be encouraged to stop off for other reasons. That was the idea of the catering manager at the airport, Brendan O'Regan, a man with a vision to transform Shannon.
On a research trip to America by boat, another idea occurred to him. If ships could have duty-free, why couldn't planes? Shannon Airport became the first airport in the world to have a duty-free shop. And that inspired an even bigger idea.
O'Regan wanted to do for industry what duty-free had done for shopping. He envisioned a special manufacturing zone attached to the airport, where international companies could make and export their goods, all tax-free. With political backing, the Shannon Free Airport Development Company was established in 1959 and was soon offering hundreds of jobs, and the new workers were promised housing.
The very first factories that came, there were 8 companies that set up here initially.
I'm meeting Olive Carey to learn about the first wave of residents who put down roots here.
And some were from the surrounding areas, of course, but a lot of them were returned immigrants from England in particular. People who had emigrated in the 1950s looking for work saw the opportunity presented here at Shannon, jobs and houses, and my own family being one of those who came back in the very early 1960s.
And what was it like growing up in this area then?
I loved my time here in Shannon growing up. First of all, there was great freedom. So coming to Shannon was just open countryside. Our playmates were the children of the industrialists who came here first. So my schoolmates were Dutch children, American, English, South African. It was a very cosmopolitan group of people who were the pioneers who came to live in Shannon in the beginning.
And were people taking a risk to come back here?
They certainly were, especially in the early days, because this was an experiment, really. It wasn't known if it was going to succeed or not, but they were willing to take the chance.
By 1961, the Ripon Piano Factory, Sony and diamond company De Beers had all moved into Shannon's new factories. 463 workers were employed in the trade zone, with plans for many more. Housing these workers was a priority for the development company. Attractive, modern accommodation suitable for families and single people was needed. Orla is discovering what was built and why.
It was the 1960s. International architecture was modern, functional, minimal, influenced by the likes of Le Corbusier and Mies van der Rohe. Multi-storey apartment living, while simple in form and function, was a new type of housing that could be constructed quickly and cheaply. Large-scale construction in concrete was all the rage at the time, in an architectural style that was called brutalism. Some said the apartments built here were like workers' housing from the Soviet bloc. It was certainly an unusual development in Ireland, and it was unprecedented in a rural context.
In the 1960s, there were still houses in County Clare without electricity or running water. Stepping into one of the new homes here in Drumkeely Hill was like stepping into another world, one that was warmer, drier, more convenient, more elegant, one that was ultra-modern.
The new residents of Shannon had to learn the features of apartment living, sharing conveniences like laundry rooms and rubbish chutes. The one-bedroomed apartments were dubbed bachelor flats, and families were enticed here with the latest in mod cons. You know, it's hard to imagine it now, but when these flats were built, they were the height of modernity. So much so that the ESB even made their own handbook for tenants to advise them how to use the new technology in their apartment. And it's called Welcome to Your All-Electric Flat. And it details how tenants can use the infrared heating in their bathroom, how they're advised to defrost their refrigerator regularly. The flats have lovely timber parquet floors and they have electric underfloor heating. And tenants were advised to only switch them on in October and then to switch them off again at the end of April. So it's wonderful to see how tenants were advised how to use this new technology. The apartments had built-in wardrobes and fitted kitchens. Every block had a mixture of 1, 2 and 3 bedroomed apartments. All of the accommodation was subsidised and only available to those working on the industrial estate. The housing for this new workforce was managed by Shannon Development's Cian O'Carroll.
Why did they decide to build multi-storey housing here on Drumkeely Hill?
It was simply because a very quick solution had to be found to the housing problem. A number of the early industries here felt that they couldn't succeed unless people came to live within walking distance of their place of employment, particularly as many of these companies operated on a 24-hour shift basis. And they came to us in Shannon Development, who had, of course, sponsored the industrial estate, and said, look, that their industries would fail unless this kind of accommodation was provided. And this was the only piece of land readily available at that time, and it was very attractive from the point of view that it commanded beautiful views of the estuary. Private enterprise wouldn't have been a viable option. So we developed Shannon because really there was nobody else there available, and we had the ability and the drive to get things done.
This was architecture as an expression of the brave new world, one where calling into your neighbour for a drop of milk for your tea would bring you out onto a walkway in the sky with a magnificent view out over the Shannon. It was a nice idea.
As the industrial estate expanded, so too did plans for a whole new town. Building a town from scratch was not at all unusual in an international context at the time. Urban planning was actually a thriving new international practice, fuelled by the need to rebuild after the devastation of the Second World War. Plans for Shannon's new town were shrouded in mystery because of its enigmatic codename, Project X. Fergal McCabe is one of Ireland's foremost experts in town planning and is familiar with the Shannon Town project. He knows why it was called Project X.
There was a secret. Brendan O'Regan's vision was for a new town, and there was a lot of local opposition. People naturally wanted the housing to be in Newmarket and Fergus or Clarecastle, but O'Regan wanted a new plan for Shannon. So he worked with the architect and town planner, Frank Gibney, and it was kept firmly under wraps and known only as Project X.
And what was unique about that particular plan?
Well, it differed from the Shannon of today in the sense that it was inspired by the Shannon itself. The whole centre was to be on the banks of the river, facing south, taking in the whole history, the romance of the Shannon, and then build backwards to the airport, unlike the plan that got implemented, which was starting in the airport and working back to the river.
What was the thinking in town planning at that time that influenced this layout?
Certainly the dominance of the car is a consideration. It was a grid. It was a rectangular grid laid on the landscape, designed to accommodate cars, large avenues, anticipating high volumes of cars. They imported what's called the Radburn system from the English new towns, whereby the housing is grouped around a little green. The car parking is separate. It tends to give you large areas of rather bleak car parking at the rear. The peculiar thing is that the individual houses have very little private space, whereas there is an awful lot of public space. So that tends to give a rather windswept appearance, a little, I would even call it, lonely. In Gibney's plan, the avenues were all curved. You'd never actually have the long vistas that you get here. There would have been more of a sense of enclosure and probably more interesting.
And not as windswept.
Not as windswept.
As you walk around Shannon's housing estates, it's easy to see how pedestrian walkways allow movement away from streets. But when you really get moving around, all the open space reminds you just how close you are to the Shannon estuary. The regular southwesterly gales howling in from the Atlantic needed another intervention.
The planners couldn't change the wind, but they could provide shelter from it. And nature's way of doing that is trees. In 1968, 28,000 trees were planted to protect the town.
Landscaping the neighbourhood became a priority. Locals also saw growth in the industrial estate and thousands of jobs materialising. But the 300 families now living in Shannon were still in search of a town centre. Housing estates sprung up everywhere, but it meant that early residents arrived into a new town lacking crucial facilities.
Town planning may have become a science, but building a community is always a more chaotic affair. The story of that community is the story of the next couple of decades in Shannon town.
Geographer Mary Green is going in search of that story.
Nothing about Shannon's development was haphazard. Critical to the project's sustainability was its new community, and there was a plan for that also.
Building a new town on an open plain beside the Shannon estuary was a huge project. The tax-free industrial zone, operated by Shannon Development, attracted international companies. Factories were built and jobs created. Accommodating workers meant building new houses. All the elements were there to build a new town. But this mightn't be enough to build a new community.
Planning consultants, mindful from the British experience of setting up new towns, advised Shannon Development on the social needs of new residents. A community officer was appointed to welcome newcomers, iron out any difficulties they may have, and promote and coordinate activities for the community.
Wolftone's GAA Club was founded in the late 1960s with the support of Shannon Development. It was an initiative that helped create an identity in a new town. Some of Shannon's first residents recall the earliest days of the community here.
Well, my father used to always call it Tiernan O because there were no old people there. And I came here with 4 children, and they always enjoyed their childhood in Shannon, where I watched everything grow, as Sean did. It was like a building site. It was just mud.
Yeah.
No trees, no grass. As I said, my kids lived in Wellingtons for a long time because there was nothing.
What was it that attracted you to Shannon?
In the 50s, we were caught very badly on the economic scene. It was so bad that, one thought in terms of pull the plug out of the Bog of Allen and let the place go down. Immigration was fierce. Out of the blue was this story of hope, change, a house and a job. And to be able to do that as part of an overall regional development, it was stirring stuff. It was practical patriotism then, being part of creating the resurrection of the country.
How did the community start to build itself?
The people who moved into Shannon, they got together and decided that we are a community, we're not just a housing estate. We have wonderful musical societies, drama groups organised here in the town. And I suppose central to everything really has been this wonderful club here, the GA Club. So through the schools and through the GA Club and the various clubs in the town, we have managed to knit the whole community together. That is where our strength really is.
The Shannon Town Project Plan highlighted the development company's preoccupation with advancing a sense of community among its town's population of 1,600 people. As stated in the plan, within a few years, Shannon will be a town in the full sense with a population of 6,000 people. It will be a place which many Irish people will regard as their home. The development company is aware of its heavy responsibility and plans to develop the town so that its residents and Ireland as a whole will be proud of it.
Interestingly, the leadership on this pioneering project came not from central or local government, but from a regional development company. I'm discussing the Newtown experiment with Father Harry Bohan, a sociologist with a long-standing commitment to community development.
I suppose if I was to put it in a nutshell now, Shannon and the developments that took place here were to be the counter-growth area to Dublin's growth. And the people who drove it were local people, committed to the area and committed to what Shannon was all about.
So community then is much more than just houses built for industrial workers.
Oh, absolutely. That's what I learned and brought back from my studies in England, that I saw the massive housing estates that were bringing about serious damage to family life. The concept here in Shannon wasn't just about housing people, it was about building community as well. Like, this was the first school, there was a community centre built, and there was a lot of services like playing pitches and things like that. They all grew up, and a lot of that was the initiative of local people. I am a deep believer, you cannot have economic development without social development, because we're talking about people, and people need people and community. These concepts have to be as much part of economic development as the economy itself. You can't measure the health of a nation by GNP or GDP. You can't measure the health of children or families or anything in that kind of way.
An increasingly globalised world brought with it external threats. Shannon's special tax status became increasingly irrelevant after Ireland joined the European Economic Community in 1973. The oil crisis in the 70s restructured global economics, and Ireland became less attractive as a source of cheap labour.
As Shannon entered its second decade in the 1970s, there were great plans for innovation and growth in the free zone and in the town.
In reality, the growth of Shannon had more or less stalled by the early 1970s. But plans were still drawn up for a futuristic new town centre, a modern and bold statement of intent for the civic ambitions of Ireland's newest town. But the plan was shelved because the population didn't grow as expected. At a time when its socio-economic achievements should have been more carefully nurtured, many feel Shannon was overlooked. As the flow of new investment into Shannon slowed, the flow of ideas out of Shannon gathered pace. Word began to spread around the world of the success of the Shannon model. The Industrial Development Organization of the United Nations became very interested in Shannon's story and how it might be relevant to countries of the developing world. Shannon was an example of how populations might be lifted out of poverty. Courses were run to share the Shannon success story with foreign visitors. Now retired, Brian Callanan was a Shannon development executive at the time.
People like Colombia in South America, Sri Lanka in Asia, Egypt in the 60s, early 70s began to look at Shannon more carefully. The big breakthrough was the involvement of China because they wanted to find a way to combine the communist system with the free market system. And I remember vividly, we had a group over, and it was a training course in 1980, led by a man called Jiang Zemin, who actually subsequently became president of China. So he was a senior minister, and he meant business. And the training course involved use of incentives. How do you manage your customs procedures? But then, as we began to talk more and more, the talk turned to rural poverty. And then we told them about the Irish famine and the rural poverty and the rural emigration that our great-grandparents and grandparents experienced. And they understood that because we were sharing a similar cultural experience. And they saw it, like we did, as a way out of rural poverty.
The Chinese immediately followed Shannon's example and set up a special economic zone in Shenzhen, a small town of 30,000 people. Today, it's a Chinese supercity of 10 million people with an economy bigger than Ireland's. There are 20 such Chinese special economic zones, and they generate nearly a quarter of China's GDP. The Shannon model has been central to China's transformation into an economic superpower. So Shannon therefore has a special place among China's leaders?
Yes, Shannon is like a kind of a holy grail, because this was the area where the Chinese special economic zones originate. And I think we've had maybe 3 or 4 deputy presidents, senior ministers, who come here just to see where the Chinese special economic zones came from.
The Shannon model has an impressive legacy. More than 110 overseas companies have opened subsidiaries here since 1959. And today, Shannon Group is still a powerful driver of economic growth for the region. The idea of the Shannon Free Zone and its purpose-built town travelled far and wide, and it was crucial in building the Ireland of today and in changing the global economy. It did achieve its purpose. Thousands of people are still living and working in rural County Clare at the cutting edge of innovation and enterprise.
Dublin Airport is our bridge to the world and the busiest place in the country. Millions of passengers arrive and depart here every year. And right at the heart of this vast complex is an 80-year-old modernist gem, the original Dublin Airport terminal building. This building is all about modernity, confidence. It's a landmark in the history of Irish aviation and in the story of building Ireland.
In this series, our team of experts in architecture, engineering and geography explores the most amazing stories of Ireland's building and engineering heritage. And in this episode, we'll discover how Dublin Airport Terminal became a cultural icon. Island nations need to connect. In the 20th century, Ireland made its mark in the development of the global airline industry, and an airport would become a gateway to the outside world.
But what was built in Dublin wasn't just any airport. It was a brave, modernist statement that echoed in a new design ethos of functionalism, glamour, and dynamism.
A building design of this importance is bound to have international influences. Architectural historian Ellen Rowley is going to investigate.
What we see here is an openness to new ideas in modern architecture, driven by clear and simple principles. In the 1930s, this building led a revolution in Irish architecture.
Engineer Tim Joyce is discovering the complicated mechanical systems at the heart of a modern airport terminal.
Beneath the striking facade of Terminal 2 is a complex building, full of clever engineering and interconnected systems, geared to process millions of people, passengers, and all their pieces of luggage.
Progress in the development of air travel is astounding. Airlines emerged in the 1920s, and daily flights were scheduled between cities. By the 1930s, intercontinental air services had really taken off, and long-haul flights were making the world a smaller place.
As transatlantic aviation became a reality, it was clear that Ireland was going to have to play a key role, both to facilitate refuelling and to keep the journey as short as possible. Planes going in either direction would have to stop over.
In 1935, an international agreement enshrined Ireland as a key stopover in the emerging transatlantic airline business. The airlines and the plane manufacturers insisted that landing on runways offered the most flexibility and potential for growth.
A Pan Am delegation came to Dublin in 1936, and their chief technical advisor, Charles Lindbergh, bluntly told the government that they needed a runway in Ireland by the following year. The government was suddenly under pressure to build the state's first international airport.
Luckily, the young Minister for Industry and Commerce, Sean Lemass, was a fan of aeroplanes, and he pushed to make it happen. The right site was essential. Shannon in County Clare couldn't build runways in time, and so attention turned to Dublin. Sites were considered at the Phoenix Park and on reclaimed land at Sandymount Strand. But Collinstown, north of the city, offered the best option. It had even been a military airbase during World War I. To get a sense of the size of the Collinstown site and why it was chosen, Dave Allen from DAA Ground Operations is going to show me around.
This would have been quite remote from the city. Do you think it was the best choice of airfield?
I suppose it's good that there was a lot of space here. Originally when it was built, it was on over 700 acres, and as you look around today, it's on a hell of a lot more than that now. It's also important that the terrain is fairly flat, well away from mountains and that type of thing as well. So there has to be good sight lines, particularly from air traffic control, so that they can see all the aprons, taxiways and runways. Because as you see today, there's a lot of aircraft manoeuvring all around at the same time.
Yeah, so thinking that 80 years ago that the choice of location was actually well made for a 21st century airport as well.
I think it is, obviously, because the city has come out towards us, you know, so if we'd been any closer to the city back then, we would have been right in the middle of the city, and then you have the noise issues. Ground officer. Copy that. Ground Operations 4 is now vacated back onto 121. I'm out of your hair there, and thanks for your help.
The job of constructing the airport terminal was handed to the Office of Public Works, and their team of architects faced a blank page. Architectural historian Ellen Rowley investigates the influences of the day that helped to shape this iconic building.
When the OPW went looking for a chief architect for the project, a 26-year-old put up his hand. He was Desmond Fitzgerald, the older brother of former Taoiseach Garrett Fitzgerald. And by chance, Desmond had designed an airport as part of his college thesis 2 years previously. So he was very familiar with modernism, that hugely influential style of architecture from the time. This building has many modernist elements, like this uninterrupted space, or the visible skeleton structure which frees up the facade, and the expanses of glazing bringing in an abundance of natural light. Its curved or curving form draw and move the traveller in, and movement and flow continue to underpin the experience of the building once inside. The 1930s saw the blossoming of a whole new philosophy of design and a new movement in architecture, the international style. Its most famous advocate was a Swiss-French architect, Charles-Édouard Jeanneret, universally known as Le Corbusier. This architecture prominently featured steel and glass and white rendered concrete. The curved terrace is a key feature of early modernist architecture. It's an inside-out room where flat roofs become useful and monumental. Here, at the airport terminal building, curved terraces become viewing platforms to share in the excitement of the airfield. Earlier architectural styles were all about applied decorative detail to surfaces. Decoration around door frames, decoration around windows. But here, it's the shape and structure of the building itself that matters. The architects are designing a building to serve a purpose, but they give it artistic flair too. This is the marriage of form and function, a key characteristic of the international style. Shane O'Toole writes about architecture. We met up to discuss what was so revolutionary about this building.
Internally, the expression of the building is about the future. It's about a future that is far away from the grimy, smut-cloaked 19th century slums of Ireland. It's white, it's spotless, it's hygienic, it's clean. It's a brave new world. And the white is saying that the minute you walk in.
What image did this building inscribe upon the visitor?
This building was described as a liner by one of the first passengers to fly in from England, because people were out on the balconies like passengers out on the decks of ship liners. And remember, Le Corbusier had used ships as an important metaphor for modern architecture. And that placed, for the first time, an Irish building at the heart of international modernism. And it's incredible that it's been designed in 1937. It's finished by 1941. And you have to think Desmond Fitzgerald, the lead architect, is only 30 that year.
Yeah, wow.
These are kids. I mean, nobody in their 20s would be given the opportunity to design a building of such national and international significance in Ireland today. It was a brave new world where youth was being given its head, but understandably so, because only 20 years earlier, the revolutionaries themselves had been kids. So these people had forged a state in their 20s. Why couldn't you give your best young architects in their 20s and 30s the most important building in the state to design? Because it has to be new, it has to be international, and these are the people who will have the vision for the future. These young men and women. Give it to them.
There was certainly a lot at stake with this project. It was the first high-profile airport building ever attempted in Ireland, and the OPW design team, led by Desmond Fitzgerald, were under pressure to get it built. The design specification, what the building needed to do, had to be worked out, and the design itself would have to be special.
So what was finally commissioned was this, the original Dublin Airport terminal building. And you can see from the original design drawings and from these elevations that there's a crispness of detailing and a lightness of touch. And you see that in the building itself, and the light actually reflects off the glassiness of the building and gives it a transparency. The public have access to the ground floor and then vertically up to these terraces. So they would have been packed with people, making this feel like a really welcoming building.
As so often happens on big construction projects, the design specification changed. What was originally planned as 3 stories was now to be a 4-story building. But the curved shape and curtain wall glazing were retained. From above, the rounded ends of the plan resemble wings. The design responds to the shape of the airplanes themselves. The shape and form of any building defines its character. And this building is very much informed by its curved shape. But it wasn't just a design flourish. Instead, it was an inspirational development, not of an architect, but of a French naval aviator. Albert Bernard Duval realised that airport layouts would be more efficient if planes could get close to the building, and more planes could get closer if the shape was long and curved. This Duval plan is evident in scores of airports built across the world during the late 1920s and 30s. It was clearly on the radar of Desmond Fitzgerald and the OPW team. They consulted international architecture journals, airports and airlines, as the terminal at Dublin is a perfect example of the Duval plan. The shape of the building very clearly illustrates the logic of air travel, but it also had to be functional. And these plans illustrate exactly how that function worked. On the ground floor, you had the public areas where the public arrived into the building and travelled out to their airplanes. And then increasingly, as you move up the building, it becomes more managerial, organisational. The Met offices on the second floor, all the way up to air traffic control on the roof. This was an efficient, elegant design and prototypical for the new industry of international aviation. Construction of the terminal was more or less complete by 1940, but the escalation of war in Europe or the emergency in Ireland changed everything. Dublin's brand new state-of-the-art airport terminal was put on hold. 3 of the 4 grass runways were ploughed up to grow food during the war years.
Normally, a building as unique as this would be published and circulated in architectural journals upon completion. Drawings and photographs of Dublin Airport, however, were prohibited from publication out of concerns for national security.
And so, this innovative building stayed out of the architectural limelight until after the war, by which time it was already 6 years old. Engineer Tim Joyce is over in Terminal 2 investigating a particular challenge for modern airports. When thousands of passengers travel, they bring thousands of items of luggage.
The baggage handling system stretches out across 9 football pitches, has more than 6 kilometres of conveyors, driven by 1,476 motors. When you take a plane from Terminal 2, your luggage also takes a trip, and it's a fascinating one. At the turn of the millennium, Dublin Airport was bursting at the seams. The Dublin Airport Authority took a decision to double capacity and build Terminal 2 to handle 15 million passengers a year. Not only was this the largest construction project in the history of the state, but it had to be completed on a site that was still functioning as an airport, the engineering equivalent of open heart surgery. This building's design faced significant challenges. One of the first systems that had to be reimagined was the traffic layout for the entire airport. Usually, you could move a building to run a road through. That was not an option for the country's busiest airport. Terminal 2 has many systems engineered to do specific jobs, and they work like the organs of a body. Whether electrical or plumbing, 200 interdependent systems run the building. Moving vast volumes of passengers through Terminal 2 also requires moving vast volumes of air as efficiently as possible. The public areas are designed to accommodate thousands of passengers every hour. They stop at counters, they sit, they eat, they stand around, but nobody lives here. This building is designed to keep people moving. And of course, the problem of moving people and passengers around the 60,000 square metres of Terminal 2 also needed clever engineering to make the best use of this floor space. I want to find out more about the baggage system. In a building this big, with so many different check-in desks, we all worry if our one bag is going to get lost. Moving millions of passengers requires moving millions of pieces of luggage. The solution is a spectacular piece of systems engineering. I'm checking in to check out what happens to your bag. Hiya. I want to check in one bag, please. Luggage is directed from check-in along a 6-kilometre network of conveyor belts to collection areas and then onto the aircraft. Every item is barcoded and the system tracks every piece individually, calculating the most efficient route to get each bag to its destination on time. Billy Ennis is bringing me backstage to get a better view.
Well, Tim, all the bags come through the central point from check-in. They're going to come in through the very centre of the operation here and turn left onto this line. When they come to this point, the bags are scanned. I think there's your bag there, Tim.
Yeah, that's mine.
That's your bag. So that bag is going to be actually scanned, and what happens now is it has to go through the security process and go into the X-ray machine there.
The bags go on a rip-roaring journey, heading in all directions, swerving up, down, left and right at speed. I wasn't surprised to learn that the computer system controlling all this is the same technology used on roller coasters.
We can handle multiple sizes of bags here. We have out-of-gauge lines that will handle the bags that are too big to go on our normal lines.
We're heading for the automated sorter. It's a busy motorway interchange for luggage. Each item has its own tray, so the system knows its exact position at any time. Billy claims luggage won't get lost.
Well, what we're looking at here behind us is what we call our tilt tray sorter, and it's the heart of the baggage system. This machine can handle up to 4,000 bags an hour when we're at our busiest period, which is typically in our summer period. So when the bag is delivered onto this sorter, the bag is put on a tray. The computer on the sorter then takes over once that bag is read by our scanning system on the sorter, and that's where the real intelligence starts. It tells that tray that that bag is on, that's your bag. It's now unique. I know what flight is going on. I know what carousel and what customer or airline to deliver to downstairs. This machine is a finely tuned piece of apparatus that will deliver your bags from check-in to the point of collection by the operator or the airline in less than 7 minutes on average, which is pretty impressive.
In 1949, less than a decade after it opened, Dublin Airport Terminal was already dealing with twice the number of passengers that it was designed for. In its design, the building has the shape and aura of a majestic ocean liner. There's no doubt that this building evokes the excitement and sophistication that's always been associated with international travel.
The sweeping curves and floating balconies reinforce the theme of dynamics in the building, but it's in the detail and in the materials that we really see the idea of travel as glamorous and luxurious. The check-in counters were made of walnut and sycamore, and these staircases were lined with travertine marble, with bronze balustrades, and topped off with these lovely timber handrails.
Everything about the building here suggests quality. The backroom offices were timber panelled, but the public areas were really designed to impress. There were bars and restaurants located here, and even a ballroom. The airport became a go-to destination for special nights out, and was a fashionable wedding venue for Dublin's jet-setting socialites. I met design historian Linda King to find out more.
So we're here in the ballroom at Orla, as you know, which was meant to be a magnificent space. Apparently it had an amazing sprung floor for dancing. And just down the corridor, you would have had the restaurant, which was run by Johnny Opperman. One of the best examples of how luxurious this was as a space and as a destination. If we look at the menu here and just see, this menu is from the late 50s, early 60s. It's very French, a lot of butter, a lot of cream, but there are dishes like sole aer lingus, which is same as sole bonne femme, but with tomato and lobster.
Wow.
Which sounds interesting. You know, if you wanted to really impress somebody, you brought them to the restaurant at the airport. So it's a very different concept to what we would understand about airports today.
The original design conceived of more than just the bricks and mortar of the building. Can you tell me a little bit about that?
The building is an example of what we call Gestamtkunstwerk, which was this German word that was in circulation in the late 19th, early 20th century, used by a lot of the modern movements. It was about designing a building, but everything within the building, doorknobs or furniture or whatever, you actually thought about the whole thing from the outset. So Dublin Airport would be a really good example of that. As you've seen, there's some magnificent details with the staircases and the marble and the use of brass.
Why was that important?
I think it was important with a lot of the early infrastructural projects of the Free State that they were landmark buildings designed to give a message to the outside world about Irish progress and modernisation, and they were also a message to the population as well as to Ireland's independence, Ireland moving forward.
So in terms of cultural identity, what do you think the intention behind the building and the language of the building was trying to say?
It was speaking to an Ireland that had yet to emerge, creating an infrastructure that would be more used by future generations. I mean, very few people were travelling up until the 1950s or 1960s. So it was very much aspirational, and it was very much about Ireland's new place in the world as a sovereign state. When countries typically got independence in the 20th century, one of the first things they did was found an airline, because it was such a symbol of sovereignty and it was a connection with the outside world. And the airports that supported the aircraft were very much part of that.
For generations, Dublin Airport has been one of the most visited places in the country. Today, 32 million passengers pass through it. The original terminal building still stands proud in the middle of the airport, engulfed by an enormous contemporary complex. And yet its splendour still catches the eye.
Dublin Airport became a symbol of Ireland's confidence, independence and modernity, reflecting the aspirations of a developing island nation. Iconic and beautiful in its form, the terminal building helped to build an image of this nation as fundamentally modern and outward-looking. In the world of air travel, the original Dublin Airport terminal building helped put us on the map. In 1922, the new Irish government set about solving its capital city's appalling housing crisis. Dublin had some of the worst slums in Europe, and a radical housing scheme would have to be built within walking distance of its city centre. 1,500 homes were built in Marino, on Dublin's north side, and they are just as desirable today as they were in the 1920s. These homes offered comfort and dignity through clever design, and above all else, a bright future for Dublin's working classes. What they built here in Marino was a landmark public housing initiative, and vitally important to the story of building Ireland.
Building Ireland explores some of the most exciting stories from Ireland's building and engineering heritage. And this time, we've come to explore the garden suburb of Marino. This suburban public housing scheme, inspired by radical town planning ideas from the Garden City movement, was the first of its kind in Ireland and one of the first in Europe.
It remains a prime example of the garden suburb idea, a public housing development designed with people in mind, with access to nature, public space and facilities.
Innovative features like indoor toilets and front and back doors for everyone were new to Irish public housing. Architectural historian Ellen Rowley is discovering what was so special about these houses.
There was an elaborate master plan for Marino, but despite this common approach, there was great variety in detail and 10 different house types were built.
But Marino wasn't just houses. Geographer Susan Hegarty is looking into what was done to build a community.
Schools, shops, a library and a health centre were all built as part of an ambitious master plan. I want to explore the rural and urban landscapes that put Marino on the map.
At the turn of the 20th century, Dublin, then the second city of the British Empire, was notorious for its tenement housing and poor sanitation. The crumbling Georgian mansions of the gentry were now occupied by thousands of casual workers and their families who struggled to earn a decent wage. In 1913, during a year of industrial strife, 7 people were killed and 100 left homeless when 2 tenement houses on Dublin's north side collapsed.
The Church Street collapse caused public outrage and led to an inquiry. It reported that 20,000 families were living in one-room flats in tenements.
A tenement museum is now located at 14 Henrietta Street, itself a notorious tenement back in the day. I'm meeting housing policy analyst Rona McCord.
A place like this, you could have over 100 people living with families all basically in one room. They found 36% of people were living in tenements, no running water and very little heat. And most of these people would have been considered the working poor. As the city has been drained of resources and more people have been crowded in, you have an increase in diseases, things like tuberculosis and very high infant mortality rates. So it's all to do with the cramped nature of housing. Disease doesn't know class, it just spreads. And at the same time, there was no alternative accommodation being built. So you ended up with the density increasing and people living in more and more poor conditions as time went on. So the political pressure around housing, it wasn't just a question of people campaigning for housing, it was a question also of people being worried about the issue, the middle classes and the political classes, and thinking that living so close together in tenements, this industrial class, if you like, the transport workers and so on, who were being organised into trade unions, were talking to each other, there was a bit of a red scare, if you like, going on, and they wanted those people dispersed. So if they figured if they housed people, that this threat would subside.
So you have a city that is gaining in population, but at the same time is becoming poorer.
And more unhealthy.
The challenge to rehouse people then becomes huge, actually.
Yes, so there was obviously a huge need, and I think from the start of the century up until around the housing inquiry in 1913, there was a gradual understanding of what that need was and a political pressure growing to find some solutions to the housing crisis.
Dublin Corporation wanted to build houses and had acquired 50 acres of rural land on the northern edge of the city at Marino. Exciting plans for a large housing scheme were drawn up in 1914, but nothing happened.
World War I interrupts momentum. The Easter Rising destroys the city centre, and the War of Independence paralyses progress to build housing.
Dublin wasn't alone in its housing problems. Many of Britain's big industrial cities had similar issues. Dickensian slums were a legacy of the Industrial Revolution. One social reformer had a vision to change all that. A man with a very Dickensian-sounding name, Ebenezer Howard. He came up with the idea of the Garden City, a combination of the best of town and country. Howard argued that the cramped city slums were morally corrupting and bad for the productivity of the working class. His Garden City would be a new kind of town with a healthy blend of city and nature, arranged in small clusters of urban and green space. After the establishment of the Irish Free State, the administration moved quickly on the social housing issue. £1 million grant, a massive commitment, was approved by the new government in April 1922. Within weeks, contractors broke ground on the state's first public housing scheme. Architectural historian Ellen Rowley is looking at exactly what they built.
The Marino scheme had propaganda value for the new state. Quality housing would be provided for citizens to a standard not seen before. This was going to be an alternative kind of urban living. Every family moving here would have an individual house with its own front door and garden. Suburban living for the masses was to be the future of housing for Dublin. City architects like Horace O'Rourke were charged with designing mass housing. Following the British example, O'Rourke introduced variety. There were 10 different house types, all two-storey, in terraces of 4, 6 and 8 units. Terraces were staggered and corners were canted, breaking the lines of view. Each terrace has a different outward design, a distinct sense of character from that of its neighbour. The endless rows of Victorian housing, built for workers across industrial Britain, would not be repeated here. All houses had a ground floor living room, a parlour and kitchen scullery, with a larder and coal cellar. Depending on the type of house, there were 2, 3 or 4 bedrooms upstairs, and every house was planned with a bathroom. What we see now as ordinary, that is, an indoor toilet, was in fact extraordinary. I want to find out more about these houses, so I'm meeting local conservation architect Fergal McGurl at a home he's recently restored. Cycling around Marino, I noticed a great variety of detail and colour. Can you tell us about that?
I think they used a lot of variation in external finishes to break up what effectively was a very large estate of 1,500 houses. The roofscapes also, I think, are a particular characteristic of Marino. For example, you see on this house another house in the estate where they used the terracotta pan tiles on the roof, and they're particularly noted at, say, corners and intersections where they seem to delineate different parts of the layout. Slating was engaged or used extensively within the estate as well. It's quite a characteristic of the area, particularly in the mansard blocks, like the block behind me, where the slating effectively became the front elevation of the upper floors of the house.
Marino Estate was built at an interesting time. Can you tell us something about the materials and the fabric used?
Well, Ellen, it was a very interesting time in terms of construction technology. We were transitioning from building in what was called a traditional way, which is the way the Victorians and the Georgians had built, with things like solid leaf brick walls, lime mortars, lime plasters. And we were transitioning into the modern era where we're starting to build with things like concrete blocks, cavity walls. Like, for example, the cavity wall was a very new technology at the time. This house, I was involved in some of the work on it. It's got a fair-face concrete block finish. There's a lot of variation in the texture of the blocks. I'd speculate almost that these blocks were made on site, because they don't, to me, look like a factory-made unit. It looks to me like they were almost handmade locally. So it was quite a brave and innovative move for the Irish Free State to build one of their first major public housing schemes with this, I suppose, in some ways, untested technology.
Beyond the masonry and mortar, the challenge of transforming buildings into happy and healthy homes also required planning and shaping the outdoor space. Everyone was to be provided with their own front and back garden to encourage residents to grow their own vegetables. A large proportion of Dublin's population were migrants from rural areas. The thinking was that they had a deeper connection to agriculture and to the land. The approach reflects an Ireland striving to establish itself as an independent, self-sufficient nation. This was architecture and planning with a social purpose, to improve the everyday lives of working people. How that environment was shaped would be crucial to the success or failure of Marino.
The original 1919 plan for Marino was greatly influenced by the fashionable garden city philosophy, with housing radiating from a large central boulevard, creatively laid out so that residents had easy access to parkland. However, the plans changed, giving the eventual layout more of a garden suburb identity. Joe Brady from UCD's Geography Department has a particular interest in Marino because he grew up here. To find evidence of garden city thinking, Joe suggested we get a bird's eye view.
If I take you back to the 1890s and say if Dublin Corporation was building an estate this size, they would probably have built a very geometric suburb with all of the roads at right angles and running parallel to each other. But this is a very different concept. So here we are right in the circle, and you're looking at something which is quite distinctive. There's nothing like it. Look at the geometry of it. But also look at the variations that are in it. What really comes to the fore is the changes in colour. And this is all designed to try and give you an impression of the countryside in the city.
So Joe, tell us what we're looking at here.
These are in fact cul-de-sacs, an arrangement of houses with their own green space. But it's private because one road in, one road out. And the only connectivity is the interesting connectivity behind the houses. You can walk in behind the houses and do all sorts of things there. And I must admit, as kids, we did all sorts of things in the lanes, as we called them. The whole thing is that this is a neighbourhood, and the circulation patterns are designed to get people moving around each other, meeting each other, but at the same time, there is no sense that this is a gigantic suburb built at all the same time. What you have are a variety of different urban spaces, and each of these little spaces creates their own community.
The original design for Marino proposed a sophisticated hierarchy of public spaces and a wide array of different house types. Due to cutbacks, the final design was less distinct. But in spite of that, because of the scale of the houses, the arrangement of the public spaces, and the fact that you can drive into it but not through it, gives Marino, as it built, a real sense of community. Geographer Susan Hegarty is discovering more about the area.
I'm doing a bit of urban orienteering and rediscovering the outside edge of Dublin City. Before this massive housing scheme was built, this area was all wide open countryside. The Marino housing scheme was largely built on the old estate lands of the first Earl of Charlemont, James Caulfield, who left us a notable architectural legacy. The most famous landmark of the area is Marino Casino, a folly built by Lord Charlemont in the late 1700s. Like many aristocrats of his generation, young Lord Charlemont undertook the Grand Tour of Europe, visiting the sites of great art and architecture of the classical era. Italy clearly made an impression on the young lord. On his return, he remodelled his house and called it Marino, and built this little house, or casaino. It's hard to imagine now, but even in the 1920s, this was the edge of the city. Dublin inner-city residents would have regarded this as the countryside. Corporation planners mapped new access and transport arteries into the area to give it connectivity, and to help define the shape of the growing city.
By far the biggest and most impressive of these access arteries is this one, Dublin's 100-foot cement highway, because this was one of the first places in Ireland where poured cement was used for road construction. The main carriageway is 40 foot across, with two particularly wide 30-foot pathways. We now know it as Griffith Avenue, and it's the longest tree-lined avenue in Europe.
Once the Marino housing scheme got underway, plans were set in motion for public transport and amenities. It's no surprise that a brand new Catholic church was built for the brand new parish of Marino, with schools to cater for 1,500 children. Other services, including a health centre, were also built. I'm heading for the Tuesday Club, a group for local senior citizens, to learn more about life here since the 1920s.
I was born in Marino 85 years ago, so that was my connection.
And has your family been here, obviously?
My father and mother bought the house in, I think it was in 1924.
I came when I was 2, 1936, so we came from Essex Street.
It was great to move to, especially after being, so many people in the centre of the city. Like there was nothing, only just fields all along Fairview.
What makes Marino so special as a place?
Like if you were short of sugar, you'd go next door and that'd be great. And sure, the lady next door used to make dresses for my sister and my cousin and her daughter, but it was completely different now. You see, there was no money really in those days.
Everybody knew one another, and as I said, kids all played together in the green.
We were all rare together, Now, you didn't go really out of... We live in a circle, in a green, and we didn't really leave that. We all played together, and we went to school together.
And so it must have been important for the parents as well to see this happening.
Yeah. You could put your children out and watch them from the houses, because it was absolutely a great idea. They all had gardens. We all had gardens. The gardens gave, how would I say, a little bit of dignity. Pride. Yeah, pride. Good girl. Our parents came from inner city out into the suburbs, and they were proud of their houses. They were very proud of their houses and their net curtains and all things like that were washed and polished, and don't do it like that now.
After the first phase of 248 houses was completed, 4,500 families applied for them. The cheapest house cost £400, about €25,000 in today's money. Distribution was ultimately by lottery. But other houses being built in Marino also attracted attention.
One of the more interesting features here is that the houses at the edge of the scheme appear to be bigger, more impressive, and of a higher architectural standard. These are the houses of the so-called reserved areas.
These Marino houses were privately built for private sale, and they were far more expensive. Ruth McManus has researched and written extensively about Marino.
What was the purpose of the reserved areas?
It was a pragmatic response to a problem. The corporation wanted to build high-quality housing at the edges of the scheme, the main roads along the edges of the scheme, the main frontages. It couldn't afford to do it itself, so it decided instead to lay out these plots and make them available for other builders. It was done for the very first time here at Marino. It was such a success, not just in terms of housing quality, but also in adding social mix to the scheme, that the corporation decided to continue with it, and it continued to apply this idea of reserved areas at all of its schemes for the next 50 years or so.
So, in a sense, it was kind of master planning the area as a whole in terms of both social mix, but also a variety of design.
Yes, they wanted to have high-quality housing. This was the sort of the shop front of the scheme. It was showing off the best of the best here.
Only families with a minimum of 4 children could apply for houses under the public allocation scheme. Dublin Corporation opted for a system of rental purchase, Residents would ultimately be owners rather than tenants, buying their houses with mortgages lasting over 40 or even 60 years, paying the corporation directly. It meant that only applicants in regular paid employment could afford the repayments. Dublin's tenement poor were effectively excluded.
Do you think Marino was designed to be special?
Well, I suppose one of the things that you find when you come to Marino, if you're not familiar with it, is how quickly you get lost in what seems to be this maze of streets and beautiful green areas and so on. And while that design is not very useful if you're trying to get around, it actually adds to this sense of community and enclosure, I think. And again, I suppose when they were designing this, they were drawing on the best of the Garden City movement. So they pretty much knew what they were doing, I think, in that respect. So you get this. The scale of Marino is manageable, I think. It's a very human scale. Everything is sort of nicely proportioned at this human scale. And the overall size of the scheme, I think, works. 1,400 houses. It's big enough to create a community, but it's not too big.
And do you think, as a public housing initiative, that it was a success?
It had a unique combination of things that happened just at the right time in the right way. It was the mix of, and the combination, I suppose, of the design elements, the garden suburb idea, the mix of people who came out here. You know, they were described as the aristocracy of the working class in one of the newspapers. But what they were doing was taking that group of people out of the mix in terms of the tenements. So better houses in town would then be available, and it sort of had this filtering effect, or levelling up, it was sometimes called as well.
It's interesting that was by design. You know, it sounds quite deliberate.
Yeah. I suppose it all came together so beautifully at Marino. You might wonder, why don't we have hundreds of places like this? And I suppose the cost of developing Marino was very substantial. So when the corporation continued its programme in Drumcondra, for example, they compromised on size. They later on compromised in terms of variety and design, because all of those things add to the cost. But here at Marino, they wanted to make it beautiful and the best it could be. So it's sort of a tantalising image of what could have been, I guess.
Almost a century after its construction, Marino's original homebuyers might not recognise the $500,000 price tag for some houses around here. But they would have no difficulty recognising the streetscape. It has hardly changed.
Marino was an ambitious development by a new state that wanted to house its people with dignity. Maybe it was too high a benchmark. Maybe it was too idealistic. Maybe it was too expensive. All we know for certain was that it was never repeated.